Synchronizing our dietary habits with the circadian rhythm, the biological clock that is embedded in almost all organisms on our planet, is proving to be a crucial factor in our health. This internal clock, which spans an approximate 24-hour period, not only regulates our sleep cycles, but also regulates a host of physiological processes that influence our metabolism and energy balance. The circadian clock works by modulating hormone secretion and enzyme activity, which in turn influences the metabolism of nutrients. Hormones such as insulin, which regulates blood sugar levels, and ghrelin, which controls feelings of hunger, show fluctuations in their concentration depending on the time of day. This means that the same meal can produce different metabolic responses at different times of the day. A fascinating example of this effect is the different response of blood sugar levels to meals eaten at different times of the day. Studies have shown that postprandial blood sugar increases are lowest after breakfast and highest after dinner. This difference is illustrated by the larger area under the blood glucose curve after dinner, indicating less efficient processing of food. So, the postprandial blood sugar rise refers to the increase in blood sugar levels after eating a meal. When we eat, the pancreas begins to secrete insulin to bring blood sugar back to normal within 1 to 2 hours. In people without diabetes, the amount of insulin is finely regulated to prevent blood sugar levels from rising too high. However, problems can arise in people with diabetes because either no insulin is produced, see type 1 diabetes, or the body no longer responds adequately to it, see type 2 diabetes. In such cases, a meal rich in carbohydrates can lead to a sharp rise in blood sugar, which can lead to long-term damage to blood vessels and diabetes-related complications. Control of postprandial blood glucose rise is particularly important because high blood glucose spikes after meals are associated with the development of macrovascular complications such as retinopathy. Modern diabetes management aims to minimize these spikes to protect blood vessel health and reduce the risk of complications. In a specific study examining the effects of eating a late dinner, participants spent 2 nights in a controlled environment. After an adaptation night, they were randomly assigned to 2 different groups to assess the effects of feeding at different. The results confirmed the importance of timing of food intake, as the same meal late in the day caused a greater increase in blood sugar levels. These findings highlight the need to consider not only the what, but also the when of our diet in order to maintain harmony with our internal clock and therefore optimize our metabolic health. In another study examining the influence of mealtime on blood sugar levels, 2 groups were fed an isocaloric diet consisting of 4 meals. The first group received a larger dinner at 6 p.m. and a small snack at 10 p.m., while the second group did the opposite at these times. Both groups had breakfast at 8 a.m. the next day. After a break of 3 to 4 weeks, participants were reassessed to experience the other intervention. Regular blood sampling at scheduled times revealed that blood sugar levels increased after meals in both groups, but the peak level was 18% higher after the 10 p.m. dinner than after the 6 p.m. dinner. In addition, blood sugar levels remained elevated for 4 hours longer after a late dinner. Interestingly, blood sugar levels were similar the next morning, but after breakfast, blood sugar rose significantly more in the late dinner group, which may indicate impaired insulin sensitivity. The authors concluded that late eating can cause overnight glucose intolerance, and the effects may have been more pronounced had the snack been skipped. Evening glucose intolerance could be caused by the sleep hormone melatonin, which is released in the dark and inhibits insulin secretion. Since insulin is responsible for the uptake of glucose into the cells, and thus for the reduction of blood pressure, is responsible for the sugar level, an inhibition of insulin release by melatonin causes the blood sugar level to remain elevated for longer after a meal. Additionally, insulin action is less effective in the evening due to reduced insulin sensitivity. Evening insulin resistance, where our cells become less sensitive to insulin, and consequently more insulin is needed to regulate blood sugar levels, can be metaphorically viewed as a temporary diabetic reaction. This reaction causes blood sugar levels to be elevated after late meals and to remain elevated for longer. In the long term, This can lead to health problems, including an increased risk of diabetes and possible impairment of brain health. That's because elevated blood sugar levels, even in the upper normal range, have been linked to greater loss of brain matter in areas such as the hippocampus and amygdala, which are important for emotion regulation, learning, and memory. Coordinating food intake with our internal clock could therefore be crucial for health. It is recommended to finish the last meal of the day at least 2 to 3 hours before bedtime. For those who want to take it a step further, skipping dinner, also known as dinner canceling, could be an option. This approach can have a positive effect on your health. Thank you for your attention, and as always, we wish everyone a long, healthy, and happy life. Until next time.